Okay.
Yes, we can see that.
Yeah, thank you for hosting the conference. Thank you, Ali. Thank you, Professor Liu, for including me in the program. So, like Ali started, how is technology affects our profession? I'm just to share my insights on this topic, and I want to start with some examples, like how AI machine learning affects the accounting profession. I want to start with some examples of the AI related to our profession. And then after that, I want to go over some summaries of the studies which we have seen so far. So I was helping review financial studies, hosting FinTech conference. So for the past 3 years, we have 500 submissions. So over the submissions, there's a trend on how the questions people are examining, and so I summarized those research questions. Also, I've talked to a lot of industry experts. So I'm going to summarize some of the trend regarding the emerging technology, and so that's the second thing I was talking about. And also, I'm going to conclude with some challenges and opportunities for our profession in speaking of this emerging technology. So yeah, so I want to start with some examples. We all know that there's a strong sentiment that technology is going to rise and change our life. But it seems like something really important to us, but it's kind of, to me, to a lot of people I know, they think it's still a little bit intangible and remote. And so I want to present several concrete examples here so you guys can see it's actually literally happening and it's changing our life, even the way we work. And I want to start from first example. So in the first study, what we did is, you guys know the AlphaGo. AlphaGo is AI system which can beat human players for the Go game. And what we did is we developed alpha analysts. The alpha analysts can predict any stock price. So let's say Google. So let's say we want to predict Google stock price. The alpha analyst can crawl all of Google's public information, including all the press release, financial information, everything about Google. And then once the AI crawl all of Google's information, every single information, we analyze the information and make a prediction. And then we horse race the the AI prediction with human prediction. And so the purpose of this exercise is to see what's humans' incremental skills that machine do not carry. So we identify several things. For example, human can understand institutional background better than machine about the firm. Human can understand the management team better than machine. Human can actually understand infrequent event better than machine. So there's a lot of incremental value human have while machine cannot replace. And so that's good. That's good about us. So the purpose of the exercise is how exactly we can help our students. How we can prepare our students to survive in the age of AI. So the idea here is we should help our students to learn something machine cannot do. So in that sense, our students will be incremental to machine, complementary to machine, instead of being replaced by machine. So that's the idea of this exercise. We trying to horse race the AI system and the human, and trying to identify what's the complementary skills human have, and we try to provide implications for our curriculum for our accounting and master students. And then that's the first study. So the second study is it's follow up. Like so if all the news annual report are read by machine instead of by human, how do manager disclosure behavior will change, catering to machine instead of human? So we all know that in traditional age, like manager will trying to make human readers happy by disclose good news, hiding negative news. But in the age of AI, the manager need to hide the news that is sensitive to machine, which might not be sensitive to human. So this is the study showing that right now about 90% of news, press release, annual report actually are read by machine instead by human. And managers are changing their disclosure behavior to cater to machine and then compared to in a traditional period, manager trying to cater to human readers. So these are the examples like the accounting, the emerging technologies actually change the way manager is manager firm, also change the investors' competitive advantage. And there's some other studies. If you guys are interested, you can go my website to see all of my work using AI machine learning to analyze these pictures and also mutual fund narratives to identify their risk assessment. So these are the, like I said, I want to start with some concrete examples of AI, just to show that while some of the emerging technology sounds remote or intangible to us, but it's actually happening not in academic study, and also this practice actually is happening in the industry. A lot of ideas I was talking about here is actually generated from conversation from industry experts. So we just provide systematic evidence and replicate some systems that industry are actually employing. So this is I want to concrete some start with some examples. So and then some of you may wonder, so what's the strength of accounting, like with the facing this rising of technology, how can accounting survive? So we actually just had a meeting with our advisory board with all industry leaders. So the way we're trying to position our accounting is we have the first access to the data. So because you can look at all the data we are talking about here: proxy statement, annual report, conference call, and so all this data actually accounting profession trying to provide assurance for this information. And by providing assurance, we have first access to this data, and we have in-depth understanding of the data. And then, so I think that compared to other business major like ecom, marketing, information system, we do have an advantage of understanding this data and have first access to data. That kind of granting us the competitive advantage in the age of AI, because AI has to be fed by this unstructured data, and we are kind of claim to understand this data better than anyone else. So that's why I think accounting do have some competitive advantage in the age of emerging technology. And that's why I think a lot of schools actually trying to add this kind of unstructured data analytics into their curriculum, so they can kind of show the advantage of accounting major. So and then, like I said, I want to summarize some of the trend in the emerging technology. The observation is from either my collaboration from Review of Financial Studies, from the submissions. We categorize the submissions. We can observe some time series trend, and also by some interaction with industry leaders. So for each of the categories here, I'm going to talk about 3 directions. I'm going to talk about what industry do, what academic do, and how exactly we can add that to our curriculum. So the first one, I think when we start the FinTech conference, most of the majority paper is about decentralized finance. So what does decentralized finance mean is it's more about distributive ledger. So it's about blockchain. We start from blockchain, cryptocurrency. But now you can see that the industry is moving along from the cryptocurrency. They are more about the metaverse, Web3, this kind of decentralized organization. So these are the new applications of blockchain. And I think that's the future. Cryptocurrency is fundamental to facilitate these new applications. But with the rising of this kind of new Web3 and the metaverse, we have a promising future of using this kind of blockchain technology and distributed ledger technology. And so you guys know Facebook just announced their metaverse system. They showed a pretty good platform. People can interact in the platform, and so this is something I think in the industry there's a promising future for the application of this technology. So for academic research, most of the study I have observed are theory based. I think because there's a lot of optimization in this study and also lack of data. So most of study in this area are theory-based. There's some data-driven study in this area, but it's not the majority of in the stream. So also for curriculum, at least in the US, I think it is getting more and more popular. Most of schools are offering a FinTech class, blockchain class, and so at least students need to understand how exactly this kind of distributed ledger system can affect our career. So this is the first direction, and then as the second year and third year of FinTech conference, we see more and more AI and FinTech for decision making. So it's a little bit different from the first one. The first one is decentralized finance, more of a blockchain based. This one is more of using AI to analyze data and for decision making consistency. So we have some like a breakdown here. We have AI for asset pricing management, AI for household financing, AI for climate and sustainable finance, AI for startup, small business, AI for bank loan contract, AI for cybersecurity. So if you guys have a chance to go through some of my website, I have some more concrete description on each of the directions. So basically, this is a rising area in the FinTech area. So we see that there's more and more this type of paper emerges over the last periods, and more and more people using the AI to analyze unstructured data, either help asset management or help household finance or help climate or help everyone. So this is a very promising area. There's a lot of decision making. We need help from AI. So the third category is policy, more policy. So when firm adopt AI or adopt FinTech, with that adoption affects the firm positively or negatively. So it's more of a policy study, and at the firm level, sometimes is at a market level. Sometimes if you study regulatory policies at a market level. So it's similar to traditional deep studies. There's no much technology in terms of technology development. There's no much in that type of study, but the topic themselves is about technology, how adapting technology affects the firm or affects the. So there's a lot of interesting area in this policy making, because will AI be fair to everyone, and also gender issues. So all these are interesting questions we saw from the literature and from industry interaction. So these are like a brief summary of what I see from the 500 submission with RFS, and also summary of my interaction with industries, and some curriculum change according to this technology. So another way to also classify the FinTech and the machine learning studies, we have three types. The first one is, you can see a lot of studies, they just use machine learning to extract one variable from the data. So for example, a simple way is, we have the recent paper, maybe like I earlier talked about, we can use machine learning to extract managers' risk assessment. So once you have the risk assessment extracted from the textual data from language, and then you use that risk assessment to complete the study, use traditional OLS. So basically, the machine learning is just a tool to extract some useful information from unstructured data. So this is the first type of study we can see. A second one is the topic itself is AI. So like I earlier talking about, we build the AI analysts, the machine analysts. So we spent like 3 years building the system because earlier we only can beat 30% of Wall Street analysts. So after a couple of years, now we can beat about half of Wall Street analysts. So the topic itself is AI, and we have to build our AI system. So this is another type of study. The third type of studies I just mentioned is just more deep in deep about what's the implication of policy. So another way to classify all this machine learning and AI study, you can see that the first one is information retrieval. You can just using some machine learning to get the variable. The second one is study the AI and build the AI. The third one is more on the policy side. So I also want to share some challenges of this type of study. So the first challenge people I normally see is if you just want to sell some like fancy technology, normally it won't work. Normally people want to see how much theory contribution you have by using technology. So basically, if you if we want to sell technology, which is I would say this is most advanced technology, normally people will say, what do we learn from it? So people are more interested in what kind of interesting economic story you can give us by using the technology instead of to selling the technology as an advanced tool. So basically, people are more focused on questions be answered by the technology, not technology themselves. So that's the first thing I have seen from my editorial process, and also how to make the technology understandable to a broad audience. So, for example, neural network, deep learning, these are very complicated model. How we can interpret this model to business scholars, even without knowing some computer science background. This is also, I think, an opportunity for us to actually to make the technology accessible to more people. And then, and also sometimes we have to justify why you use this technology, why not that technology. These are all common challenges in this type of study, but they are doable. These are the challenges, also opportunities, like I said, because this is the different focus between us and computer science scholars. For computer science scholars, they don't care about economic stories. They don't care about whether should justify the technology. But for business scholars, we need to make sense of the stories, economic stories. Also, we need to make the technology understandable to non-computer science background. So this is also opportunity for us compared to different focus that the computer science scholars will have. So this is one chart just to show where business students should stand. So this is a normal team from either consulting firm or IT firm. So normally this is a structure. So we start from the customer team here. The customer team will have the so we'll have the product manager. Product manager, their job is to observe the client demand, so customer demands, and then they do some simple data analytics. So they basically they collect demand from the customers, and then they pass on the demand into the implementation team. The team will try to implement the data model for the product manager to make the customers happy. So basically, you can see that the product manager is on the front line, and then they get what customers want, and they do some preliminary data analytics, and then they pass on the demand into manager, tech lead. Tech lead and manager trying to understand what product manager want, and then they pass the request to data scientist. Data scientist will code the model. So this is how normally the consulting firm and IT firm works. You can see that it's a transition from what customer need to how exactly coding the model. You can see this is the transition. So what I want to make a point here is our students normally land as a product manager and a manager or tech lead. That's how business students will land by learning, because these are the positions need a combination of domain knowledge and data analytics. So the product manager, they need to understand customer demand as well as some data analytics skills. While look at the data scientists, they don't need much understanding of the customer's demand. So they don't need much domain knowledge. They just need the solid coding skills to implement the model the customer wants. So most of data scientists are hired from the computer science major or statistics major. So this is the point I want to make. While we offer some data analytics class, we shouldn't make the class too identical to the class in computer science or data analytics. If that's the case, the firm they just hire data scientists from the statistics department or computer science department. It's a better fit for them. So for our students, we need to train them how to use this data analytics in their own domain. So for our accounting, how to use this data analytics to analyze accounting issues, how to analyze finance issues. That's how our class should be designed for. So by design that combine the data analytics with the domain knowledge, we can help our students landing the position of product manager or tech lead. And then maybe they don't need that solid coding skills, but they do need understanding the domain knowledge of the customer's needs. Compared to the data scientist, they can, they need a solid coding skills, but they can be excused from the domain knowledge. So this is how we should position our students and how we should design our curriculum, make our students more competitive compared to other quant-based engineering students. So I want to conclude my last slides. There's a lot of opportunities in this area. So for example, for PhD students, I think we can have more courses for PhD students for them to learn this kind of emerging technology. I have been teaching PhD seminar at different US universities, Hong Kong, and in also mainland China. And also for master students, because there are too many master student undergrad students, I think develop a textbook which have a domain knowledge and the data analytics. The perfect combination of the two area will be good textbook for the undergrad students. And also I think this area also bring up the opportunity of industry collaboration and academic research. We always worry our research are actually not read by the industry experts, and also industry experts sometimes the question they are interested. Sometimes we don't feel really tempting to us. So I think the unstructured data AI, this is a good area which actually interests both academics and industry experts. So I think this is an opportunity for our students and faculty as well. So I think that concludes my presentation. And yeah, again, thank you for organizing the conference. And I'm looking forward to any feedback, like Annie says, reflection on my discussion.